Hello everyone. This video is a continuation of end of chapter exercise of chapter 1, the use of coordinates. And in this video, question 11 to 16 got covered. Let's look into the question 11. Let P, Q be points of trisection of AB. So AB is one line segment that has been divided into three parts. That is the reason they have mentioned as trisection. And those three parts are equal to each other. That is what trisection. You would have heard bisect, right? What is the meaning of bisect? A line can be divided into two equal parts. That is bisect. So trisect means a line has been divided into three equal parts. That is what there in this first statement, with P closer to A and Q closer to B. So there is one line. So first we will assume one line, that is AB. So this is A, this is B, and it has been divided into three equal parts. So I can divide like this. Over here, P is closer to A, so I'm making the point P over here, and Q is closer to B, so I'm making one more point Q over here. So using your knowledge of how to find the coordinates of the midpoint of segment, how would you find the coordinate P and Q? Do this for the case when the points A and B is given like this. So what are the points for A? So it is 4 comma 7, and the B point is 16 comma minus 2. Yeah, so we need to find the point P as well as Q. We don't know as of now. So what I'm doing, we'll write this as x1 comma y1 and x2 comma y2 for Q. Okay, so this is what we are going to find it. And how they are asking you to find, using the midpoint formula, right? That midpoint of a segment we already learned, right? What is actually the midpoint? It's nothing but the average of x as well as the average of y. So using the midpoint, we are going to proceed with this. So first, what we can consider, we will consider the line segment APQ. Okay, so in APQ, P is a midpoint, right? Yes, so because this and this is going to be equal, so in the line segment APQ, P is the midpoint. So now we can apply the midpoint formula. So what is the midpoint formula? Over here, x1, y1. So for P, what are the coordinates? X1 and y1, which is equal to, and average of x as well as the average of y. So can we write? So 4 over A, and x coordinate of Q is x2. Okay, so I can write this as 4 plus x2 by 2 and 7 plus y2 by 2. Okay, so from this formula, what I can conclude, I can write x1 is equal to 4 plus x2 by 2 and y1 equal to 7 plus y2 by 2. So from this, can we make a linear equation? So this 2 is a common denominator. We can move that to the other side. So 2x1 equal to 4 plus x2. So that I can write this one as 2x1 minus x2 equal to 4. So mark this equation as 1 as of now. And same way this side, if you continue, you will be getting 2y1 equal to 7 plus y2 and 2y1 minus y2 equal to 7. This is equation 2. Okay, so now the first part got over. Now we are going to consider this PQB. So PQB line segment, where in that Q is the midpoint, right? So for Q, we are going to apply the midpoint formula. So can we do that? So what is our midpoint over here? The Q, and Q's coordinates are x2 and y2. So which is equal to average of x. So it's nothing but x1 plus 16 by 2 and then y1 minus 2 by 2. So now we can separate the x and y coordinate. So x2 equal to x1 plus 16 by 2 and y2 equal to y1 minus 2 by 2. So now move this 2 common denominator to the other side. You will be getting 2x2, and if I move this x1 to the other side, I'll be getting minus x1 equal to 16. So mark this equation as 3. And over here it is 2y2 minus y1 equal to minus 2. This is equation 4. So as of now, we got 4 equations. So using this 4 equation, we are going to find the unknown 4 variables, that is x1, y1, x2, y2. Okay, we'll see that now. So how can we proceed with this? So now we can solve equation 1 as well as equation 3 because both the equations are having unknown variable as x1 and x2. So now we can solve that one. So how can we solve? So 2x1, the first equation. So first I will write like this. First equation gives us 2x1 minus x2 equal to 4, and write this third equations also in terms of x1 x2 and then constant. If you write like that, what you will be getting? Minus x1 plus 2x2 equal to 16, right? This is what your third equation. But if I write like that, I don't have the coefficient to be equal. So either we want x1 coefficient or x2 coefficient need to be equal. It is not equal in both the cases. So what I'm doing, I'm going to multiply equation 3 throughout equation 3 with a 2. So what you will be getting? Minus 2x1 and plus 4x2 equal to 16 into 2 is going to be 32. So now what we have made, actually we made the coefficients to be equal for this x1. It may be sometimes same sign it will be there, sometime it may be an opposite sign. If it is an opposite sign, because we want alternate sign in order to cancel the particular term, it is already existing as an alternate sign, so I can cancel this, so that we are getting out of one variable. Now only one variable is left over, so easily we can find the value of that variable. So here minus 1 and plus 4, so minus 1 and plus 4 is going to be plus 3x2, which is equal to 32 plus 4, again we need to add it, it is going to be 36. So for finding the value of x2, 36 by 3, which is 12. So we have found the value of x2, which is equal to 12. Now how to find the value of x1? Substitute this x2 in any one of the equations. So can we substitute in equation 1? So 2x1 minus 12 equal to 4. So 2x1 equal to 4 plus 12. 2x1 equal to 16. So x equal to 8. That means x1 equal to 8. So we got the value for x1 and x2. So what was that? x1 is equal to 8 and x2 equal to 12. So the same way we are going to find the value for y1 and y2 also. Then we'll replace the coordinate p and q with the values. In order to find the value of y1 and y2, we are going to compare the equation 2 and 4. So equation 2, it is in the form of y1, y2, but equation 4 is in the form of y2, y1. So first we will rewrite this: minus y1 plus 2y2 equal to minus 2. So we have rewritten the fourth equation in term of y1, y2. So now we can compare 2 and 4, right? And also I already told you, when you are doing the solving of two linear equation, at least one of the variable coefficient need to be equal. Over here in the second equation, the y1 coefficient is 2, here minus 1, and y2 coefficient is minus 1, here it is 2. So it is not matching, so we need to convert in order to have the coefficient to be of same. So how can I do that? So first, from the second equation, I will write the equation just like that: 2y1 minus y2 equal to 7. So now for the fourth equation, I'm going to multiply the fourth equation throughout with the 2, so that I can match the y1 coefficient to be equal, right? So already in the second equation, the y1 coefficient is 2. So if I multiply the fourth equation by 2, I will be getting here also 2y1, right? But there is a negative sign, so it is going to be minus 2y1. And then with the 2y2, if you multiply, we'll be getting 4y2 equal to minus 4. So this is what we are getting. Now rechange, the equation 4 has been rechanged by this after multiplying with the 2 throughout. So if you see, this is plus 2y1 and this is minus 2y1. So when you add it, it is going to get cancelled. And same we need to do for all the things. So it is minus 1, this is plus 4. So you will be getting 3y2, which is equal to 7 minus 4, it is 3. So what is our y2 value? It's going to be 3 by 3, which is 1. So now what we need to find? Y1 value we have to find. So take the equation 2. In the equation 2, I'm going to substitute the y2 value. So 2y1 minus, instead of y2, I'm going to substitute 1, which is equal to 7, 2y1 equal to 7 plus 1. So 2y1 equal to 8, y1 equal to 4. So we got the value for y1 and y2 also. So what is our y1 value, which is 4, and y2 value is 1. So this is the values. So now we are going to implement the values over here in our problem. So what is this P? One point P intersection point is x1 comma y1, right? So we know the value of x1 y1, so it is 8 comma 4. And what about the q coordinate? Q is equal to, actually it is x2 comma y2. So what is the value of x2 comma y2? It is 12 comma 1. So this is the answer for this question. Now we'll see the 12th question. Over here in the 12th question, there are two subdivision. Given the points A, B, C, so there are three coordinates has been given. Show that they lie on a circle K, whose center is the origin 0, comma 0. What is the radius of circle K? Okay. First thing what we have to do, we need to check whether all these points are lying on a circle or not. What is the meaning of that? Whether they are lying on a circle means they are on the circumference of the circle, right? And also they mention the origin is there as O, which is having a coordinate 0, comma 0. So maybe if it is lying on a circle somewhere over here, just I am marking this like this, A, B, C. So what is the A coordinate? 1, comma minus 8. And what about the B coordinate? It is minus 4, comma 7. And the C coordinate is minus 7, comma 4. Maybe if these 3 points are lying on a circle, then what actually need to be proved? So when I am joining all these points towards the center, all are going to be a radius. That means all are going to have the same value. Radius of one circle is not going to change anywhere, right? Everywhere it is going to be the same. So I am going to prove, if I proved OA equal to OB equal to OC, if I prove this, I can say, yeah, all these 3 points are lying on a circle and the distance is going to be the radius. So our first division is going to get over. So can we find the distance of OA, OB and OC by using the distance formula? So what is distance formula? Root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now directly I am applying OA. So OA means O point is 0, comma 0. A is 1, comma minus 8. So now if you apply x2 minus x1, 1 minus 0 is going to be 1 square. Minus 8 minus 0 is going to be 8 square, which is 64. So you will be getting the answer as 65. And then we need to find what is the length of distance of OB also. So if I find OB, again applying the same distance formula, minus 4 minus 0 is going to be 16, and 7 minus 0 is going to be, the whole square is going to be 7 square, which is 49. Again it is also giving 65 only, square root of 65. And we need to find the distance of OC2. So over here, minus 7, 0, the whole square is 49, and 4 minus 0 is 4, 4 square is 16. So this is also coming as 65. So all OA, OB and OC all are equal. It means it is equal to radius. So what is the radius? So we concluded that all these points are lying on a circle only. And what about the radius? It is root 65. So our first part got over. What about our second part? Given the points D as well as E, check whether D and E lie within the circle, on the circle or outside the circle. Okay, so we need to check whether it is within the circle or on the circle. So first we are going to find the distance between OD and also OE. OE distance also we need to find. Maybe if this OD distance is root 65, then that is lying, the point D is lying on a circle. If it is lesser than this, then it is inside the circle, that point is inside the circle. If it is more than that, then it is, the point is outside the circle. So can we find what is OD? So OD equal to, first before that we'll write the D point, which is minus 5 comma 6. Yeah, so if I find OD, it is going to be 0 minus 5 the whole square, it is 25, and 0 minus 6 the whole square, it is 36. So if you added 6 plus 5, 11, balance 1, over here we are getting a 61. So obviously it is lesser than root 65. So point D lies inside a circle, lies in a circle, right? So where the point D will be, so randomly you can keep over here. point D. So it is lying inside the circle. And now we are going to find for OE also. So we'll find for OE. Before that, we'll write the point E. It is 0, 9, and we know O is 0, 0. So 0, 0 is going to be 0, square is also 0, and 9 minus 0 is going to be 9 square, which is 81. So if you solve it, we will be getting root 81. It's nothing but 9, we know, but just consider as root 81 only, because we are comparing the root values, right? So root 65 is our radius, but here we are getting the answer as root 81. Then what is the meaning? So obviously this root 81 will be lying outside. So it will come beyond the circle. So the point E is lying outside the circle K. Yes, this is what our answer. We'll see the next question. The midpoints of the side of a triangle ABC are the points D, E, F. Given the coordinates of D, E, and F. So what they are saying, so we are having a triangle ABC. So I'll draw a triangle ABC, and all these three sides are having some midpoint. So it was not mentioned where the midpoint. So always take AB midpoint as D, BC midpoint as E, AC midpoint as F. This is what an order, right? So now we can mark these points also 5, 1. This is 6, 5, and this one has 0, 3. And what is our question? We need to find the coordinates of all these three vertices. Okay, so the midpoints of the sides has been given, and we have to find the vertices. So first we'll mark with a variable A as x1, y1, and B as x2, y2, and C as x3, y3. So we are going to find all these three coordinates with the given information. For that, we need to know the midpoint formula, right? Yes, na. So for midpoint of AB, first we will take midpoint of AB. So what is midpoint of AB? So it is D. So D coordinates, you can write it as 5, 1, which is equal to average of X as well as average of Y. So I can write it as X1, X2 by 2 and Y1 plus Y2 by 2. So now you can equate X and Y coordinates separately. So what we will be getting? X1 plus X2. This 2 you can move to the other side. So with the 5, if it get multiplied, it is 10. So this is your first equation. And we'll compare now this y coordinates. So what you will be getting? Y1 plus y2 equal to 2. This is your second equation. Now we'll take the midpoint of BC. So for that, we are going to apply midpoint of BC. Then what is the midpoint? Here E is the midpoint. The coordinate is 6, 5. So when we are taking an average, it is going to be x2 plus x3 by 2 and y2 plus y3 by 2. Okay, so now what we can do? We can compare the x coordinate and make an equation. X2 plus x3, 6 into 2, 12. Okay, and then y2 plus y3, which is equal to 5 into 2, 10. So you can mark this as equation 3 as well as equation 4. Now we will find the midpoint of AC. So the midpoint of AC is F. The coordinates are 0, 3, and this is going to be x1 plus x3 by 2, comma y1 plus y3 by 2. So when you are comparing the x and y coordinate, we'll get an equation x1 plus x2 equal to 0 into 2 is going to be 0. So equation 5, and y1 plus y3 equal to 6. This is equation 6. So as of now, we have got actually totally 6 equations we have got. So over here, is there any two equation having the same variables? Okay, over here it is 3. Yeah. So over here, any two equation having the similar variable? No. One is x1, x2, one is x2, x3, another one is x1, x3. So from this, we are going to frame some intermediate equation. Then only we will get an answer. So first we'll write all the equations neatly and we will start solving the problem. So here we have taken all the 6 equations separately. So now I want to take one equation. So what I'm going to pick, I'll pick this fifth equation. So from the fifth equation, what can I write actually? Can I write that x1 equal to minus x3? or x3 equal to we'll take. Okay, so x1 equal to minus x3. Yeah, we'll take that like this. So why I'm taking like this, I'm going to substitute this value. So first we will mark this as equation 7. If I substitute the x1 value as x3 in equation 1, see, this x1 will turn to x3. Now after turning that, I can compare these two equations, right? 1 and 3. Then both are going to have same x2 x3, so it will be very easy for us to do the cancellation. So if you substitute the value of seventh equation in 1, substitute 7 in 1. So this actually came from fifth equation. Yes. So how can I get? So instead of x1, we need to get substitute as minus x3 plus x2 equal to 10, and if you write in an order, it will be x2 minus x3 equal to 10. Yes, so now coming back, now we can compare this first equation with the third equation. Yes, so what is our first equation? After rewriting x1 as x3, we will be getting x2 minus x3 equal to 10. And what about our third equation? It is x2 plus x3 equal to 12. So now if you add this x3 is going to get cancelled because of alternate sign, and you can add this x2 will become 2x2, which is equal to 22. And what about the x2 value? It is 22 by 2, which is 11. So now we got the x1 value. So once we get the x1 value, x2 value, then how can we get the other value? X3 we can easily find, right? So by from the equation 3, so in the equation 3, if you substitute the x2 value, which is 11 plus x3 equal to 12, then what about x3? X3 equal to 12 minus 11. So what is the answer for x3? It is 1. So we got the x3 value as 1. So once you know what is x3 value, then x1 value you can get, right? Because from the equation 7, what is x3? X3 equal to minus x1. What is x1? It is minus x3. So if the x3 value is 1, then x1 value is going to be minus 1. So now we have found all the three x values. Now we need to find for y1, y2 and y3. So for that, which two equation can we compare? We need to think now. So what I'm going to do, I'll take the second equation. So from the second equation, I can find what is y2 equal to. Okay, so y2 equal to 2 minus y1, right? So this y1 is going to move to the other side, so it will become minus. So now I got this as, I can mark this as equation 8. Okay, so now what I can do, over here in the sixth equation, see, in the fourth equation we have already y2, y3, but in sixth equation we have y1 and y3. So now we are going to change this y1 by substituting the eighth equation. We will change this y1 to y2. So now substitute 8 in 6. So instead of y1, what we have to write? Actually, we want y1 value, right? So here I taken as y2 value, not required. So we'll take y1 value from the equation 2. Okay, so what is y1 value? Y1 equal to 2 minus y2. So this is what we are going to mark as an equation 8. Now we are going to replace this y1 with 2 minus y2 plus y3 equal to 6. When I am substituting in equation 6, the equation 8, y1 is going to turn into 2 minus y2. So again we can rewrite, because we have two constant term over here, right? So we can rewrite this one as minus y2 plus y3, and this 2 will be moving that side, it's going to be minus 6 minus 2 is going to be 4. So now this is what our new sixth equation in terms of y2. Now we are going to compare this equation with what? Fourth equation, because that fourth equation is also having y2 and y3 only, so it is easy for us to do the cancellation. So now we can cancel these two equations. So if you add both y2 will get cancelled because both are having alternate sign. And over here you will be getting 2y3 equal to 14. So once we get 2y3 equal to 14, what is y3? It is 14 by 2, which is 7. So we got the value for y3 as 7. Now we will find y1 and y2. If I substitute the y3 value in equation 4. So substitute y3 value in 4. We will be getting the y2 value, right? So y2 plus, instead of y3, 7 equal to 10, and y2 equal to 10 minus 7. So y2 equal to 3. So we got y2 value as 3. Now again, it is so easy to find y1 value with respect to equation 2. So now substitute y2 in equation 2. So what we will be getting, y1 plus y2 value is 3, which is equal to 2. So y1 is equal to 2 minus 3, which is minus 1. So we got the y1 value as minus 1. So now we got x1, x2, x3 as well as y1, y2, y3. Now we can mark our points. So we can mark it, yes. So what is our x1 value? Minus 1. y1 is minus 1. So our a coordinate is minus 1 comma minus 1. And what about x2 value? It is 11, and y2 value is 3. So our b coordinate is 11 comma 3. And what about x3? Where is x3? x3 is 1 and y3 is 7. So our c coordinate is 1 comma 7. This is the solution for this problem. We'll see the next problem. So over here, a city has two main roads which cross each other at the center of the city. These two roads are along north and south direction and east-west direction. All the other streets of the city run parallel to those roads that are 200 meters apart. There are totally 10 streets in each direction. So first we will make a diagram for it. So there is one road towards north and south direction, and another one east and west direction. So I have marked this one, and still we have some streets running parallel to these roads, right? That main roads. So totally how many streets they are saying? 10 streets they are saying. So we'll take 10. So towards north south 10, and towards east and west we need to take 10 more. Yeah, and each street are 200 meter apart. It means what? We are going to take the 1 centimeter. This is actually looking like a graph. It's a Cartesian plane, and each centimeter is going to be taken as 200 meters. So we will mark the points now. Okay, so I have marked over here the meeting points as both the north south as well as east west. That intersection I made it as 0 origin, and towards your north south we are having what? Totally 10, right? 10 streets are running, and towards your east west there are totally 10 streets are running. This is what they are asking us to do, represent the roads and street by a single line. We did that. So over here the scale is 1 centimeter equal to 200 meter. That is so important. So this is 100 meter, this is 200 meter, like that we need to calculate. And our second subdivision is there are street intersections in the model. Each street intersection is formed by two streets. Yeah, one is running towards the vertical, which is north south, another one is horizontal, east west direction. Each street intersection is referred to in the following manner. If the second street running in the north south direction, okay, we'll take the second street is this, right, in the north south direction, and the fifth street in the east west direction. So this is our fifth street in the east west direction. Meet at where? Meet at this point, right? They are going to get intersect at this point. And how I can mark this? It is 2 comma 5. So that is given in the question itself. So it is 2 comma 5. Using this convention, we need to find how many street intersection can be referred as 4 comma 3. So 4 means you have to take in the north south direction. So here 4, and what about 3 in the east west direction? So you will be getting 4 comma 3 over here, and then 3 comma 4, 3 and 4 is over here. So they are asking that how many street intersection can be referred as 4 comma 3 and how many can be referred as 3 comma 4. Is there any possibility for one more 4 by 3 or one more 3 by 4? It's not at all possible. Only one intersection is possible. So you are going to show this by a graph. So here ends this problem. We'll see the next one. The next question is, a computer graphic program displays images on a rectangular screen whose coordinate system has the origin at the bottom left corner. So there is one rectangular screen is there. One second. Yeah, over here, we don't consider the circle as of now. So there is one rectangular screen whose coordinate system has the origin at the bottom left corner. So this is what our bottom left corner, na? There is the origin 0, 0. The screen is 800 pixels wide. So what is the meaning? On horizontal, that means horizontally on x-axis, this is totally 800 pixels are there. Till this it is there. And in vertical, that means the height wise, it is 600 pixels. It is right. And then a circular icon of radius 80 pixel is drawn with its center at the point 100 comma 150. So where is 100 comma 150 exactly? You will be getting over here, right? So from that I'm going to draw a circle. So actually the center is exactly over here. 100 and 150 will be coming over here now. So that is what. But we need radius, right? Without radius, how can we draw? That is what has been mentioned as 80 pixel. So where is 80? Over here, this is 80, right? So you can take this as a radius and draw one circle. This is our circle having the center A. And then another circle icon of radius 100 pixel is drawn. So of radius is 100 pixel is drawn with its center 250 and 230. So 250 and 230 you will be getting over here, right? So from here 250 and from here it is 230. So this is the center B with the 250 and 230 as a center. 230 as a center. Yeah. So determine. So once, and what about the radius of this circle? They have given us 100 pixels. So if you see, it is coming as 100, right? So 100 pixels. So we need to draw one more circle. Now we'll come for the question whether any part of the circle lies outside the screen. So is it lies outside the screen? No, right? So or both the circles are lying inside the screen. What screen? It's rectangular screen they talked, right? So both are, this is what the rectangular portion, no? So this one and this upside. So both the circles are inside the screen only. Whether the two circles intersect each other, yeah, the two circles are intersecting at each other. So this is the answer for this question. We'll see the next question now. Plot the points A, B, C, and D in the coordinate. Is ABCD a square? Can you explain why is the area, that means why, and what is the area of this square? Okay, so first we will plot all these points. So we need one coordinate system. So can we plot these points? 2 comma 1. So 2 is on the x-axis and over here 2 comma 1. This is point A. And then B, it is minus 1 comma 2. So minus 1 and over here it is coming, right? So minus 1 comma 2. And what about C? It is minus 2 comma minus 1. So over here it is, this one is B and this one is C, minus 2 comma minus 1. And what about D? 1 comma minus 2. So over here 1 comma minus 2. So first we need to plot the points on a graph because that is what they have told in the coordinate plane, and they are asking you whether it is ABCD is a square or not. So when can I say it's a square? Actually, when all the four sides are equal, I can say it's a square. Even for a rhombus we will say that, right? So I will tell you how to do this one. So first we will join all these lines. So we are getting one quadrilateral and we are going to check whether that is a square or not. How you will be finding? So we need to find the distance of AB, BC, CD. That means this is CD, right? D I need to write, and also AD, and check whether all are equal. So can we start doing it? So now we'll start finding the distance AB using the distance formula. I'm not writing the distance formula directly. I'm putting the formula over here. So minus 1 and this is 1, right? Yeah, 2 comma 1. Minus 1 minus 2 is going to be minus 3. Square is 9 and 2 minus 1 is going to be 1. So it's going to be root 10. So we'll check a BC value. BC equal to minus 1 plus 2 is going to be 1 and 2 minus of minus 1 is 3, so it's going to be 9. So it's root 10. So use the distance formula and check, the value will be coming as root 10 only. And over here it is minus 2 minus 1 is going to be 3 square, 3 square is 9, minus 2 plus minus 1 plus 2 is going to be 1, so it's also root 10. And what about the other one? AD value. So AD value is what? 2 minus 1 is going to be 1. 1 square is 1, 1 plus 2 is 3, 3 square is 9. So AD is also root 10. So all the four sides are equal, we have proved. But whether it is a square or not, how can I check? Because rhombus also will have all the four sides to be equal, right? So what I'm going to do now, I'll be drawing one diagonal over here and check the Pythagoras theorem. So we can join this line, just consider this as a straight line. Okay, so join this one, so we can prove the Pythagoras theorem over here. So this point is B, this point is C, this point is D, and here we got root 10, and here also we got root 10. So as per the Pythagoras theorem is what? Actually hypotenuse square equal to sum of square of the other two side, right? So what can we write? So BD square equal to BC square plus CD square. So what is BC square? That is going to be root 10 the whole square plus root 10 the whole square, which is 20. So BD square equal to 20. Then what about BD? It needs to be root 20, right? So now what we are going to do, we will find the distance between BD and we'll check whether it is coming as root 20. If that is coming as root 20, then I can say what? Yeah, that is the square, right? So we'll find what is the distance between BD using the distance formula. So what is x? 1 is minus 1, minus 1, minus 1, minus 1 is going to be 2, 2 square is going to be 4. And over here 2, and here this is minus 2. So minus of minus 2, 4. So if you do the square, it is going to be 16. So we are getting BD value as 20. Yeah, correct, right? By Pythagoras theorem also it is root 20, and even the distance also root 20. Then I can conclude, yes, ABCD is a square. Now the next question is what? What is the area of this square? So what is the square area? Side into side, right? So area of a square ABCD is equal to side into side. So which side we can take? BC into CD will take it. So both are what? Root 10 into root 10. So if you multiply root 10, root 10, root and root is going to get cancelled. We'll get 10 square unit. So this is the answer for our 16th problem. Here ends our chapter 1. We'll see the next video for chapter 2. Thank you.